Hi everyone, welcome to my channel. This video is part of a playlist on AKS, Azure Kubernetes Service Networking. What you see on my screen is a layered architecture diagram created using draw.io. I've created detailed videos on how to create this, so if you're interested in learning more about it, be sure to check that out. Again, all the draw.io files, scripts, and other content presented today is on my GitHub link below. AKS CNI, Container Network Interface, is a networking model that manages how pods communicate within the cluster and with external resources. So today we'll talk specifically about the Kubenet network plugin, and in the upcoming session, I will cover other plugins, so stay tuned. First of all, you will show you the overall architecture. We'll understand the key design points, and then we'll jump into VS Code and build the cluster from scratch. While the cluster is building, we'll talk about core concepts, inbound, outbound flows, and then we'll run validations from the command line and the portal, and we'll close it out with some quick troubleshooting tips. So let's have some fun. If you've been following along with me, our starting point is typically a brownfield environment with a classic hub and spoke architecture. So here is the hub, here is the spoke, and we have a branch connected with the site-to-site VPN. Okay, so that's our starting point. What we'll do is we will deploy an AKS cluster within a subnet. So we'll deploy a 3-node AKS cluster, and then we will look into the different types of networks. So when you deploy an AKS cluster, the 3 nodes get deployed in the node network. And then we have the concept of cluster network and the pod network. We'll deep dive into the cluster and the pod network, but at a high level, the cluster network is not visible to the outside of the cluster, and it is responsible for pod-to-pod communication and pod-to-service communication, while the pod network focuses on communication between pods in the cluster. And we'll deep dive on all of that flows as we progress through the session. So the main use case for Kubenet networking, as you can see, is for conserving IP address space. What does that mean? The fact that the pods get IP from a different network than the node network, we could efficiently utilize the node network IPs and use a different, like a /16 for pods. So we get a lot more usage, and we get a lot more pod IPs with this design. So remember, nodes receive an IP from the Azure VNet, and a subnet carved up from within Azure VNet, and pods receive IPs from a completely different address space. And so this approach, so the use case for this approach is to conserve the network space. So let's now look at let's build this cluster using VS Code. So here we are in my VS Code. Let's start all the way at the top. So I have already logged in, but if you haven't, you can use the AZ login command to log in. And in here, I'm just going to validate that I'm logged in. I have created an alias for kubectl, so I could just use K, and you can see that I already have it defined. But if you don't, you can use the command to set it up. So here I have so moving forward, I will use K instead of kubectl. So let's get the current context just to make sure. And I have no context set up. And so if you do, be sure to use these other commands to either switch the context or delete the context if appropriate. Now let's set some variables. So here I have, a generic configuration, but my variables are set up over here. So we'll go ahead and configure all of these variables, and I'll talk about these in a little bit. So the most important variable over here is the fact that I have an existing virtual network and I have an existing um, subnet over here. So these two are existing, and this cluster name needs to be unique. And there are two types of resource group. One is the resource group where the VNet exists, and other one is the resource group where we're going to deploy the AKS cluster. And we'll talk about these as we progress through the script, but in here I have set up the plugin to be Kubenet. Okay. So now that we have our variable set, let's create the resource group. So we'll go ahead and kick off that one. Let's create the container registry. Now here, let's talk a little bit about the identity and why it is needed. So I'm going to create a new managed a user identity. You could use managed identity as well, but the most important thing is that it needs the network contributor access to the virtual network. So let's create an identity, and you can list that. We'll grab the principal ID from it, and then we'll echo the principal ID. Okay. And let's also grab the identity ID as well into a variable. And as you can see, we'll just echo it. So this is the ID for the identity itself. Okay, so now that we have all the variables set, we still need to set a couple more. So let's set the VNet ID, and let's echo the VNet ID. You can see that it's my hub VNet. It's an existing VNet, and it's an existing subnet. And I'll show you this in the portal in a second as well. And let's make sure that the identity the principal ID that we have has the network contributor role to the VNet. The scope is the VNet, and then let's just verify that. Okay, cool. So now we have all of our variables set. We are ready to create the cluster. But before we create the cluster, I want to show you how it looks like in the portal before. So let's go to the portal. And you can see that I'm in the Kubernetes services, and there is no cluster deployed over here. And in the hub VNet, I have an existing hub VNet, and I have created a subnet for Kubenet subnet. It's a /24 172.16.239.4. It's a /24, and the outer address space is /16. Okay, so with that, let's look at what we need to deploy the cluster. So this command will create an AKS cluster. As you can see, we've given it a unique name that was defined in the variable. It's going to create a 3-node cluster. It will generate SSH keys, which are used for secure access to the AKS nodes. We're going to enable monitoring. And in fact, I apologize. This is the unique DNS name. This is the DNS prefix, and this is the cluster name. So kind of going back in here, cluster name is this one, and the unique. In my case, they're both the same, but this needs to be unique. And then we have network plugin. Network plugin in our case is set to Kubenet, which is the default plugin. And then our cluster cider. As we saw in the draw.io diagram, this is the service sider or the cluster network. This is the DNS server IP. It's used by core DNS for DNS resolution. And then we have the pod sider. Notice the pod sider is completely different from our subnet ID. And subnet, as you saw in the portal, is a 172.16 IP carved up from my network. And we'll assign the identity, attach the ACR, and we'll define the max number of pods to be 30. So this is number of pods per node. So with that, let's kick off this cluster creation. And while the cluster is creating, it's important to have this verbose so you can see what's going on. In case it fails, we can troubleshoot further. So while the cluster is getting created, let's jump back in here, quickly review these three networks. So here, this is the node network where the nodes are being deployed. And then we also define the cluster network and the pod network. So what we will do next is we will deploy a few pods. And also remember that in this diagram, you can see that the plugin we are using is Kubenet plugin, and this is the broader series, the AKS Networking series. Okay. So deployment. What we will do is we'll deploy these three pods. It's three replicas of a pod using a deployment.yaml file. We'll go into the details in VS Code. Essentially, this pod runs a single container based on Nginx, and it listens on port 80. So we have three different pods on one on each node, and it listens on port 80. Notice it has an IP from 10 to 44 network. And then we will deploy what's called a service. Service is nothing but it's of the type load balancer. So it is designed to expose the pods to the outside world. So we'll deploy two types of services. One, they're both of the type load balancer, but one we will expose it on the external load balancer, and the other one we will deploy it on the internal load balancer. And so this service will listen on port 8080, as you see over here, and it will forward the traffic to these three pods on port 80. There is a lot of magic that happens between how the traffic reaches from the external load balancer to the endpoints, and we will cover a very important concept of node port and study the flows. Now let's do a quick check on our cluster deployment here. Looks like it's still running. So let's look at what the concept of node port brings to the table. As you can see that each of these nodes are exposed using each of these Kubernetes AKS nodes are exposed using this port called 31836. And the most important part about the node port is that it allows you to expose the service on each of the nodes, and the load balancer will be in turn the backend of the load balancer would be talking to this node port, and then the node port will talk to the cluster IP, and behind the scene the cluster IP then talks to through the pods. So the flows would look something like this. So let's look at the flow from a user that's outside of our network. Green is the inbound flows. This user will hit the load balancer on port 8080 on a public IP, which will in turn talk to one of the node port and node port on one of the nodes, and then it will talk to the cluster IP, and then it will reach one of the endpoints. That's how the inbound flow works. And the outbound flow, so from the perspective, if we initiate what is my IP or ifconfig.me from this pod, you will see that the pod will egress using an outbound IP on the load balancer. So that's how the inbound and outbound flows work. And we'll deep dive and look at this more closely as soon as the cluster is deployed as well. So great, looks like our cluster is deployed. You can see that how long it ran. So let's connect to the cluster so we can do the deployment. So let's get the AKS credentials. And as soon as you're connected to the cluster, you can get the nodes. As you can see, we have a 3-node cluster deployed in the 172.16.239, what we call the node network, which is within the Azure VNet. And let's look at. Oops, this is not needed right now. Let's look at if there is any pods deployed. As you can see that the only we don't have any pods deployed. The only service that we have deployed is the 10.101.0.1, which, if you remember, is the cluster IP for our let's do a K-describe to understand that better. Yeah, so that's the default Kubernetes service. For you to see the DNS service, we need to look at a different. Let's look at it while we are here. So if you look at it using it's in a special namespace called kube-system, and that's where the 10.101.0.10 IP we can see, which is listening on port 53. So that's the DNS IP that I mentioned, used by core DNS. All right. So now that we can see that we have our nodes deployed, let's do a quick deployment of. Let's do a quick deployment. So you can see that in this deployment, we're going to deploy 3 replicas of using this image nginx hellos. So let's go ahead and kick off that deployment. Okay, it wants us to create the demo-ns namespace. So let's create the namespace first and then do the deployment. There we go. We have the deployment. So now we can run this command again. Let me put this command here as well. And we can see that if we define -n demo-ns, we will see that we got our 3 pods deployed, and the pods got IP in the 10 to 44 network. So anytime you run the get pods command, you do have to add the -n, the namespace, to see the pods in the corresponding namespace. So far so good. We have the 3 pods deployed. Now let's deploy the external service. So this is the YAML file for that. What it's showing you is that it will deploy the service of the type load balancer and it will expose port 8080 on the load balancer that maps to the target port 80 on the pod. Okay, so that's the external one. And similarly, we have the internal one requires this annotation. So let's deploy that. And again, all of these scripts are in my GitHub portal, in my uh, GitHub site. So be sure to check that out. So let's do this. And now you can run this watch command as it's deploying the external IP, it's deploying the load balancer, and there we have the external IP already. And then we could do similarly, we can get the pods and the service. But let's control C out of that so we can see. You could see that this is listing nodes, pods, and service, and this is the service, the external service of the type load balancer, the cluster IP, the external IP, external port, and this 303 is that node port that I mentioned. Okay, so let's also deploy the internal service. And we will again watch that one as well. So it says pending. And as soon as it's deployed, we'll get it will get an IP. So at this point, we have completed the deployment of the pods and created two services, internal and external. So while we're waiting for this, let's run a few validations. So what we will do is, since we don't have an IP for the internal load balancer yet, let's just make sure that we did indeed apply the network contributor permissions. Looks like we didn't, so this is actually good. I was going to show you this in the troubleshooting session, but let's look at why this is not working. Okay, so one of the commands that you can run for troubleshooting is you can do a kget events. Let's just make sure we're getting an IP. Oh, we did get an IP. So we must have ran this command. Oh yeah, so we did. I should have done a case sensitive. So we did run. We did run the network contributor, but one of the troubleshooting techniques is that if we didn't do this command, then we will fail. It will fail to deploy the internal load balancer, and we'll get an error, something like this, fail to connect to the load balancer. So be sure that you have this permissions, the contributor role, which we did do that. For a second, I thought we missed that. So let's just validate that we have. Yep, there we go. So we have an internal load balancer, which is now using the IP of 239.7, which is the same network as the nodes. And so now we have the two services deployed. Let's jump back into in here. So as you can see, we now have the endpoints deployed. We have the internal and external load balancer deployed. Let's look at the node port a little bit more closely. And the way to do that, the way to validate that, let's go jump back in here. And what we will do is we will look at what's called the describe command, which helps us validate what the service looks like in detail. So let's clear this out, create a little bit more space here, and let's look at this describe command. It's a very, very useful command for troubleshooting. And you can see that the ingress, load balancer ingress, this is the public IP on the load balancer on port 8080, and the target port is 80. This is the port on the pod itself, but notice this node port. Node port is where from load balancer it will talk to the nodes on this node port, and these endpoints are the pods itself. Notice those are on the 10 to 44 network. Okay, so the most important concept over here is the concept of node port, which is where the nodes are listening on that port. And similarly, we can do a K describe service on the internal service, and you can see this is the IP on the internal load balancer. So we'll jump back into the Azure portal and take a look at this as well. So let's go to the Azure portal, and here let's refresh this so we can see um, our cluster. We'll go into this resource group, and you can see that you have the cluster created. There is also another resource group that gets created, which is important. So let's open this in a new tab. And we'll search for AKS here. And you can see that this research group got created, which is where the load balancers are deployed. So let's look at first the external. This is the external one, and this is the internal one. So let's first look at the external one. And here you could see the front end IP configured, and then the backend pools are configured with, and these are the node IPs. And most importantly, if you go into the rule, it's talking to the node port. Okay, so that's the key concept. And then outbound, it will use this outbound net rule so that all of the pods will egress using this 2.41 IP. So let's validate both inbound and outbound. Okay, so so we'll go jump back into the shell over here, and let's SSH into or exec into one of the pods. So let's get all the pods one more time. So this command is pretty handy. It gives you all of the pods. We'll exec into this pod. So this command kexec it, and we'll give this name of this pod dash sh. Well, let's specify the namespace and then dash sh. So now we are in the pod. If we do IP adder, notice the pod has an IP in the 10 to 44 network. And if I do curl ifconfig.me, we are egressing using the IP on the load balancer. So kind of jumping back into the portal here. This is the IP that we are of the load balancer we are using to egress from the pod. And lastly, from here, let's look at how we can. So here I am on my desktop. So how do let's connect to one of the external services. So we'll connect to this external service. So we could do curl and then we can do colon 8080, and we'll just grab for address. So there we can connect to it, and I have a very simple Nginx pod running over here, which is the IP of the pod it's giving. If you want to see how it looks like in the portal, we can take a quick look. So there we have we are connecting to the 10.244 2.3. In this case, that's the pod we are connecting to. So let's jump back and again take a look at these flows to make sure this all makes sense. So this is again that inbound flow that we looked at from outside. This is the outbound flow. And similarly, let's look at the flows from on-prem. On-prem will be connecting to this internal load balancer using the private IP. Notice the internal load balancer has an IP on the 239.7 network. The same way, this pod, when it reaches out, and this is an important concept, when it reaches out on the internet, this pod will not get seen as a 10.244, but instead it will get seen as the node IP, and that is an important concept. So if you're setting up the VPN tunnel here, your encryption domain, your VPN would include these networks as opposed to using the pod networks. The outside Azure VNet has no idea about this 10.244. It gets netted to the IPs on the node network, the node IPs. So that is an important concept to note for the on-prem side. When you go out, you get seen as the node IP. Let's make sure. So now in this diagram, I also have a couple other things. You will see that I have documented all of the outputs that we saw. That way, even if we don't have a cluster deployed, you can see what the output of the external service looks like, the different IPs, and these IPs match the IPs that I have created on the diagram. Okay, so all of this content is in here. Be sure to check that out. And so to summarize, I want to go into one more topic, which was the troubleshooting topic. So let's take a quick look at some of the few things that you can do. There's a useful command called kget events. It will help you look at if there was any error. Remember, I said that this is a very important step. In case you missed this role assignment, assigning contributor role to the VNet, then we will run into an issue, and you can see that over there. And then a couple other things, if you want to see what identity it is using, you can run this command to verify the identity of the AKS cluster. And then you can verify DNS. I think we looked at this earlier. You can get the pods in the Kube DNS system, and this is the service that is the DNS service that is being used by the pods to do the name resolution. And lastly, you can delete this resource using this delete AZ group delete command to delete everything. So with that, I'm going to take you back into the draw IO for a few closing thoughts. And so the key use case for this type of design is kind of circling back into this simplified view, is that the nodes are on a separate network than the pods. So you get a lot more pod IPs using this design. And so I have documented some of the key use cases and design points over here. And notice how pods will communicate to the outside world using NAT um, on the nodes. And that is the reason why on-prem sees the pods as coming from the nodes IP. So these are some of the limits. And if you want to kind of think about how big should your subnet size be, I have given a simple example over here. So for example, if you had a /24 subnet for AKS, you can support up to 251 nodes, 4 IPs being reserved, and each node supports 110 pods. So 251 times 110 is 27,610 pods. All right, so that's the number of pods you can support. And this is again for the example of a /24 subnet. And we'll compare and contrast that with the Azure CNI in the next video. So again, thank you for watching. I hope you learned, and be sure to check out the next video. Thank you.